3/8 decoder need to be implemented, how many 1/2 decoders are required in order to get the requirement of 3/8 decoder? Obviously 7, right? So how it will be, right? For example, how we have solved earlier, how many multiplexes are required in order to solve 1/m multiplexer, like that, right? So if I would like to have to implement with the help of decoder, so here one device contains two output lines. Am I right? Right? Meaning that one line needed to define how many devices are required. Half decoders are required. Half size 1/2. But here my requirement is I want to get 8 output lines. In order to get 8 lines, how many decoders are required? 8/2 decoders are required. That means 4 decoders are required. For these 4 decoders, you are going to have again 4 lines. Again you are going to have 4/2 decoders are required. That means 2 decoders. Again you are going to have 2 lines. These 2 lines required to implement. So you required one more decoder. That is, I can call it as 1 decoder. Can I stop here? Yes. So meaning that total how many decoders are required here? 7 decoders are required in order to implement 3/8 decoder. Right? Similarly, can we construct for 6/64 decoder, and how many decoders are required of size 2/4? Right? Basically, how we will solve? So to get 4 lines, you require 1 decoder. Am I right? So here we changed the formula, right? 2/4, right? So 2/4 decoder required to produce 4 lines as output, right? So 2/4 decoder is going to produce 4 lines as output. So we required 1 decoder. In order to produce 1 line, you require to have 1/4 decoder, right? But point is here, I need to produce 64 lines. So 64/4, you are going to have 16 decoders, right? And the 16 decoders again get 16 lines as output. 16/4 is 4. 4/4 is 1. So total how many decoders are required here? 21 decoders are required. And how many levels are there? 3 levels, right? So this is first level, level 1, level 2 and level 3. Here also at level 1 we are going to have 1 decoder, level 2 we are going to have 4 decoders, and level 3 we are going to have 16 decoders, right? So this is what we did. If I am going to have a decoder of size m/2 power m, how many decoders are required of size n/2 power n decoders? Can you define? So basically what we did here, so we are going to take, so basically 2 power n lines as output, which requires 1 decoder, guys. Instead of taking this much complexity in terms of powers of 2, what I can do now, I will try to modify this equation as like, can I write it as log m/m decoder? Yes or no? M is separate term, 2 power m I converted to m, right? So I taken logarithm on both sides, so I got log m into m/m decoder, right? Similarly, if I made like this, it is also log n/n decoder. Now it is easy for us to solve. It's like a kind of earlier mux concept. Am I right? So now tell me, if I want to implement n lines as output, how many decoders are required of this size? 1 decoder. If I want to produce 1 line as output, how many decoders are required? 1/n decoder, right? As earlier example, right? Similarly, if I am going to have to produce m lines as output, you require m/n decoders. and to produce these m by n lines as output, you need m by n square decoders, and so on, right? So you are going to get n levels or k levels. After k levels, you are going to get the value as m by n power k, where this value will be definitely less than or equal to 1, right? If I am going to calculate this, k value is definitely going to be greater than or equal to log m to the base. Is it correct? Log m to the base n, right? So means, what is the value of m here? We have converted, right? That you have to make understood, right? We have converted. So this formula is different from Mach's formula. It may look like the same thing, but they are purely different, right? Because we represent the terminology same, different. Okay, fine. Similarly, for example, how many levels are required? K levels are required. K levels means, can I write it as summation of k equal to 1 to log m base n, and how many decoders are required? You can mention them as m by n power k, and that should be, it is also in seal form. This is the formula for to define total number of decoders required, right? For example, try to solve this one. If you want to implement a 3 by 8 decoder, using 1 by 2 decoder, how many decoders are required of size 1 by 2? So how many levels are there? How many levels you are going to get? 3 levels. How you will get that? Right? It should be from k value should be greater than or equal to log m to the base n. Right? So can I write this as log m by log n. What is log m? Log m is 3. Right? So I have transformed the formula, right? This is log m by m. This is log n by n. Log m value is 3 and log n value is 1. So k should be greater than or equal to 3 by 1, that is 3. Right? So once we know the number of levels, can you able to calculate it? So I can make it as m by n. M by n is what? 8 by 2 plus 8 by 2 square plus 8 by 2 cube. So totally we are going to get 7 decoders. Okay na? So here you have to make sure the difference. So earlier there is no meaning of log m, but here the log m is changed completely. You have to make sure it compares. Okay. So that's why I have taken an example also.